Hello everyone, this is Dr. Pritpal Singh, an MD from CMC Ludhiana, and I'll continue with my previous sessions where we were talking about the pharmacology competency 1.5. That was, this competency says describe the general principles of mechanism of drug actions. And in this particular thing, we started with the term what pharmacodynamics means, what are the various type of actions that take place, such as stimulation, depression, irritation, counter irritation, replacement, radioactivity. And then we talked about the various types of actions that are there, such as those which are through the enzymes, those which are through ion channels, those which are through receptors, those which are through carrier molecules, and those which are through the physical and chemical properties of the compound. We also further highlighted about the receptors. We talked about the receptor affinity, the receptor uh, selectivity, the receptor specificity. We talked about the intrinsic activity of the receptors, where we classified classified and defined the agonist, antagonist, partial agonist, inverse agonist, and all these sessions have been covered in my previous sessions on this particular competency of PH 1.5, which is available on my YouTube channel DRP Smith 1. What I'll do is I'll start with where I had left in the previous session. We were talking about these four types of receptors. We talked about the ion-gated ligand-gated ion channels. We talk about the metabotropic receptors. We talk about the kinase linked and related receptors. And now today we will be starting with the nuclear receptors. So if you have any questions or queries that pertain to this particular topic of pharmacodynamics, where we are talking about the mechanism of drug action, you could get back to me. You write down on my chat box, and I'll definitely get back to you. In the coming sessions, I would be further highlighting the core competency pharma PH 1.5, where I would be talking about the various factors that tend to modify the drug action. So we have already covered the inotropic receptors. We have covered the G protein couple receptors. We have talked about the kinase ring receptors, and today we talk about the nuclear receptors. So as the name suggests, these receptors are present inside the cell. They are present in the cytoplasm, and these receptors, they bind to either steroid hormones or they bind to thyroid hormone. Now, what do they do? Now, these receptors, what the first thing that any ligand or drug that needs to bind to this receptor, what it needs to do is it needs to enter the cell. That means that that particular drug should be lipophilic. So because this receptor is located inside the nucleus, so drug has to enter inside the cell. It has to bind to that particular site of the nucleus, then it would bind to a specific DNA binding domain. And once it binds to this DNA binding domain, it leads to gene transcription, translation, and protein synthesis, which ultimately leads to the cellular effect. Now, what is more specific out here is the DNA binding domain of all these nuclear receptors. Now, this DNA binding domain has two loops of 15 residue, which are knotted together by clusters of 4 cysteine residues surrounding the zinc atoms, which are known as zinc fingers. Downstream is the hormone binding region, whereas upstream is the variable region for genes transcription. Now, what does this mean? Downstream and upstream. Now, normally what happens is in all the other types of receptors, all the other 3 types of receptors, the amino terminal is the amino terminal is the terminal for binding of the ligand, and the carboxy terminal is for the drug action. Out here it is opposite, so that is why downstream is the hormone binding region and upstream is the variable region for gene transcription. Now, what happens when a steroid, or let's say a hormone, binds to this particular receptor? Once the steroid binds to this receptor, there is a change in receptor conformation. And as noted previously, in type 3 receptor, there is the first essentiality, or the first criteria is that there is dimer formation. Once there is a dimer formation, then this particular dimer formation leads to binding to a specific sequence of nuclear DNA, which causes an increased RNA polymerase activity. There is increased production of mRNA, which occurs within few minutes. But because protein synthesis or new proteins are involved, synthesis of new protein are involved, so physiological response takes day to weeks. Now the specificity of is there at the amino terminal and the DNA binding domain of the receptor, and this particular receptor has a key role in drug metabolizing enzyme and transporters such as PPAR. Now let's talk about how this particular receptor works. So this is the receptor complex which is bound to HSP90, that is the heat shock protein 90, uh, which is one of the inhibitors that tends to bind to this particular receptor so that this particular receptor is not auto-activated. Once the steroid binds to this receptor, this heat shock protein dissociates from the receptor, and then this particular, you can see these DNA binding domain, which we were talking about, 416 residues and something like zinc fingers. They bind to a particular domain of the DNA, and once they bind to the domain of the DNA, they lead to altered transcription of a specific gene. Now, these were all regarding the various types of nuclear receptors. Now, when we talk about another important thing that is there, that is the receptor regulation. Now, receptor is regulated at each and every point of time. So these receptors, they mediate events that are controlled by receptor expression. This is not a static component, it is a dynamic component which tends to change or respond to change in ligand concentration, and this change is initiated by the signal transduction pathway. The short-term regulation means there is desensitization, and the long-term regulation is either increase or decrease in the receptor expression. Now we could say, we could go ahead with the phenomena of development of tolerance, or with the phenomena of supersensitization for long-term absence of an agonist binding to a particular receptor. And this is mainly seen in drugs that act on the CNS, which have a slow onset of action or are drug dependent. Now, these receptors have also been associated with certain diseases, and we know that autoantibodies are directed against a particular receptor protein, as seen in myasthenia gravis, and mutation leads to gene for transfer. Mutation could be at the receptor for the gene, or it could be at the signal transduction protein. Now, we have various autoantibodies, we have various conditions where these autoantibodies are developed. We have myasthenia gravis, we have hypersecretion of thyroid hormone, severe hypertension, cardiomyopathy, and epilepsy. Now, this gene mutation, it leads to mutation of the receptor for ACTH, or it could lead to permanent switch of thyrotopinyl luteinizing hormone. There could be adenoceptor polymorphism, or there could be gene encoding for growth factor receptor. So this is regarding the pharmacodynamic components of receptors, and I hope I have been able to clear some air on this particular aspect. And if you have any queries, please get back to me. Write down in the chat box, and I'll definitely get back to you. I wish you a very happy learning and hope you have a great day ahead. Thank you so much for your patient hearing.